Hello there and welcome to today's lesson. This is your friend and teacher Kaunga Samuel. Really today we are just going to continue from where we ended in the previous video on second theorem. So this is a continuation lesson. Okay, without wasting much of your time, those of you who are new to this channel, consider subscribing. Please, if what you're going to watch here is going to really make you learn, don't forget to share, don't forget to like, don't forget to subscribe. Straight into the lesson. So today I'll just concentrate on tangent related properties. Without wasting much of our time, let me just make known to you what a tangent is. To those of you who may not know what a tangent is, this line here is called a tangent. Why is it called a tangent? It touches the circle at a single point. Any line that is going to touch a circle at a single point like this, that line is qualified to be called a tangent. Now take note, at that point where the tangent touches the circle, okay, there's a line that goes to the center of the circle. This line is called the radius. Straight away, let's just look at theorem 1, okay, or property 1 under tangent theorems. Property 1 under tangent theorems. Here we are. Okay. So, property 1. A tangent to a circle touches the circle at one point. I've already explained. The angle between a tangent and a radius is a right angle. Great. So you can see the angle between the tangent and the radius is always a right angle. So suppose that here I have my O and I have my A here. There is A here. Then we're simply saying angle OAP here, okay, is going to give you 90 degrees. Similarly, if I have D here, then we can say angle DAO or OAD. So OAD, this angle there, is also going to be 90 degrees. Straight away, let's just jump into property 2. Property 2 under tangent is related to the lengths. Okay, look at that. So the two tangents drawn from a point P outside the circle are equal in length. If they are equal in length, this is a special property which is so useful under circle theorems. Look at this. If these guys are equal in length, and suppose I drew a line here, suppose I drew a line there. I drew a line like that. Can you see that? What have we formed there? This and that is giving me an isosceles triangle. Also, the angle there, from an external point, I have an isosceles triangle there. Very, very important. Straight away, let's look at examples. I hope you are learning, okay? Number 1, let's look at example 1. I'll call these examples, but they are questions, but let's just call them examples. So let's find, okay, though this one is not related to tangents, but for the purposes of learning, let's find the value of x. So from this circle here, find the value of x. So meaning find angle COD. So find the angle marked x. Simple as that. So there I'll say, okay, solution. So for this one, you can see that OC, okay, OC, this is OC, is parallel to AB. So because these are parallel lines, then we can say this angle here corresponds to that angle. These are corresponding angles. These are corresponding angles. Because these are corresponding angles, and I know from the previous video that if this is my diameter, this line here, which passes through the center of the circle and touches the circle at 2 points, at A and at D, this line is a diameter, meaning that this has divided this circle into two. So now we can rely on the property that says the angle inside the semicircle, okay, that angle is going to be 90 degrees. So I know that this angle here is going to be 90 degrees from the previous video. Right. So meaning if I find the value here, if I find the value there, okay, if I find the value here, this angle here is going to be exactly as the angle there. So let's just find that angle. So therefore, I'll say x. Since these are corresponding angles, I'll use that. I'll simply say x. X is equal to 180 degrees minus 180 degrees minus 90 degrees plus 34 degrees. So this is going to give me 180 degrees minus 124. 90, 34, I'll get 124, 124. So 180, okay, 180 less 124, I have 56. So I have 56 degrees. This is my value for x. Another question. Let's look at this question there. For this question, great. Still we are finding the value of x, y, and z. Now let me show you certain things that you have to see even before you attempt this question. Look at this. Can you see that? From the center there to the circumference, this is a radius. Also from the center to the circumference, this is a radius. This is a radius. This is radius, and that is radius. And you know the characteristics of radius, they are equal in length. That simply means here I have this one, and that one is an isosceles triangle. Okay, it's an isosceles triangle. If that is an isosceles triangle, then it is easier for me to work with this. If I can see that and I know that this is a tangent, if this is a tangent, then I am assured that at the point of contact, there's a 90 degrees. So there's a 90 degrees here. Can you see that? There's a 90 degrees here. Can you see that? That's great. There's a 90 degrees there. So let's just now solve this thing because it is easy now. You can see them. So we're going to say, okay, for me to find the value of x, I'll simply say, okay, x is going to give me 180 minus 2 multiplied by 52 degrees. Okay, 180 degrees minus 2 multiplied by 52 by 2. Now I have 104 there. So this is 180 degrees minus 104 degrees, which is going to give me 76 degrees. 76 degrees. This is my value for x. As simple as that. Let me find my value for z. Okay, before z we can even find y. There's no challenge. I'll clear that. Okay, so meaning here I have a 52 degrees. Look at that. Here I have, this is 52 degrees. This is 52 degrees. 52 degrees. If that is 52 degrees, then y, okay, y is going to give me 90 degrees minus 52 degrees. So y is now going to give me 90 less 52, 38 degrees. 38 degrees. That is my value for y. Let me find my value for Z. So to find my value for Z, I'll clear this. Okay. To find my value for Z, I'll simply say, okay, this triangle, I'll use this triangle. Angles inside this triangle should give you what? Give you 180. Therefore, I'll simply say, okay, therefore, I'll say Z is going to give me 180 degrees minus 90 at the point of contact there. Can you see? Here at the point of contact here, there's a 90 there. There's a 90 here at the point of contact. I hope you're able to see that. Then we're going to say, okay, if this is 90, then I'll simply say my x, I have already found my x to be what? 76, isn't it? So this is plus 76, okay, degrees there. So what I'm now going to have is 180, okay. So 90 plus 76, now I have minus 166 degrees, okay. Therefore my Z is going to give me 14 degrees. This is my Z. As simple as that. And then you can underline. Okay, that's great. Let's just continue. Wow, 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 wow. If you're liking this video, please give it a thumbs up. Let's just continue and look at another example. Let's look at this one, which is quite interesting. Find the value of x, y, and z. Look at that. This is a tangent. So remember, when you check, this here is a straight line. This is a straight line. Angles on a straight line do what? Great, I can hear you say an answer. So angles on a straight line, they'll add up to 180 degrees. So for me to find x, I'll simply say, okay, x is going to give me 180 minus 50 degrees. So x is going to give me 130 degrees. That is my x there. Okay, as simple as that. If my x is 130 degrees, now take note, this is the radius from there to there. I have a radius. If you're able to see this, then second theorem is very simple. I have a radius, can you see? Meaning that what I'm going to have there is an isosceles triangle. That and that. Can you see that? Isosceles triangle. So meaning for me to find the value for z, okay, or y, it becomes very simple. For me to find the value for y, I'll use a property to say at the point of contact here, the angle between this line leading to the center and this one, the angle there is 90 degrees. So therefore y, okay, y is equal to 90 degrees. 90 degrees. As simple as that. If y is equal to 90 degrees, then what is z? I know that, okay, if this is 130, so the angle that is going to be here, the angle here is equal to the angle there if we use isosceles triangle. So let's find these angles which are denoted by that red ink there. I'll simply say, okay, to find that angle, I'll say, okay, 180 minus x is 130. The result divided by 2. I'm now going to say, okay, 50 divided by 2 divided by 2. I'm going to have 25 degrees. Okay, so meaning that these angles here, this is 25, this is 25 there. This is 25 degrees, that's 25 degrees. So is this one here 25 degrees? Okay, now if this is 25, then what is that angle? Therefore angle z, okay, therefore z is going to give me 90. Remember, at the point of contact, so this is a point of contact here, point of contact is just there. At this point, now we are simply saying this angle here is 90 degrees. This is 90 degrees. I hope you're able to see that. that is 90 degrees. And out of the 90, I already have my 25, my 25 degrees, meaning that Z is now going to be, Z is simply going to be 90 degrees less 25 degrees. So this is now going to give me 65 degrees if my math is on point there. So that is going to give me 65 degrees as my Z. As simple as that. Okay, without wasting much of our time, if this video is helping you, please give it a thumbs up. Okay, like this video, share it in your WhatsApp groups, in your various WhatsApp groups, so that together we can learn, together we can revise. Okay, we can revise. Invite somebody to this channel, call your friends to this channel, make them really subscribe. Okay, let them subscribe to this channel. Let them learn something. As they learn, they're going to revise and together going to move. I hope you are being helped so far. All right, so let's just continue as we look at some ECZ question papers. So I'll give you two ECZ question papers. Let's look at questions there. Let's just look at this example there. Is it ECZ? Let's look at ECZ. Okay, that one there. Okay, so for this one, the question says in the following diagram, AB and AC, okay, AB and AC are what? Tangents. You can see tangents. Great. Now look at this. AC and BE produced meet at D. When you produce AC and BE, these they'll meet at D. Meaning, remember that theorem from property 2, from an external point, the length from an external point, from this point here, so A is an external point, the length, so AB and AC are the same. And you've got this line there. What does that mean? This simply means there is an isosceles triangle that has been created. So this and this, they're going to be the same. Can you see that? Meaning that it is now easier for me to find the value for A. So I'll say, okay, solution. So I'll simply say, okay, A. So for A, I'll simply say ACB is equal to, okay, ACB is equal to 180 because there are two base angles there. So 180 minus 54, the result divided by 2. So now I'm going to have 180 less 54, that's 126. Okay, 126 divided by 2. Okay, so 126 now divided by 2, what I'm going to have is 63 degrees. This is my angle ACB. Great, you are done there. Okay, very easy indeed. Now let's look at angle CBD. Angle CBD is this one. CBD. So the angle is here. The angle is here, CBD. This is the angle we are looking at. CBD, this angle there. That is our CBD. Can you see that? Now, how do we find that one? Remember this angle here at the point of contact. Remember that? The second property of tangents, at the point of contact. So our point of contact is here. So meaning this line leading to the center here and the tangent, the angle between this is going to give us 90 degrees. So meaning that this angle there should give us what? 90 degrees. Let me use a different ink. So this one here is 90 degrees. Can you see that? Now, if that is 90 degrees, already I have found that my angle ACB is equal to angle ABC. So meaning that this here is going to give me 90. So therefore, CBD is going to give me 90 degrees minus 63 degrees. So 90 less 63, okay, I'm going to have my 27 degrees. That is my angle CBD, 27 degrees. Now, what about angle CDB? So this one was CBD. Now, what about CDB? So CDB is this angle there, this angle here, CDB. Okay, what is this angle here? Okay, what is this angle there? That is what they're asking us. Now, look here. I will just clear this. You can rewind the video a bit if you want to look at it nicely. So I'll do that so that you are able to see it nicely. So here I'll take this path. I'll simply say angles inside this triangle, angles inside that triangle should always add up to 180 degrees. I have found the angle here to be 90 degrees and this angle. So the angle there is going to be very simple. So I'll simply say, okay, angle CBD, okay, angle CBD. So for C, this is B, by the way, this is B. So for C, now I'll say C, angle CBD, CDB rather, CDB is going to give us, so this is going to be 180, okay, less, so let me just clear this, we write nicely. So CDB, let's call it CDB. CDB is going to give me 180 less 54 plus 90 degrees. So this is going to give me 180 less, okay, 54, 90, we are going to have 144. So 180 less 144, now going to have 36 degrees. That is my angle CBD. Okay, that is my CDB rather. That is my solution. Okay, so here I have my answer here is going to give me 63. Okay, so this is 63 degrees. This is 27 degrees, and that is going to give me 36 degrees. As simple as that. Okay, great. This is how you answer your ECZ question. This came actually in 2022. I think this was an internal paper. So 2022 ECZ internal. Okay, internal. Great. Let's look at the last ECZ question and then we can call it a day. If this video is helping you, please don't hesitate to subscribe, okay? Invite your friend, share this video, okay, so that together we can grow this channel. Your subscription is really going a long way. Okay, let's look at another last question here. So the last question is this one here. Okay, I did not take note the year into which it came, but it's from ECZ past paper. So there we're going to say, okay, you can see I have a tangent here, a tangent. Very good. So let's just find the solutions to this without wasting much of our time. So here BOD, remember the angle at the circumference, okay, is half the angle at the center. So this angle here is going to be double the angle at the circumference. So BOD is that angle there. So this angle is going to be, okay, BOD. So solution. So A, angle BOD is going to give me 2 multiplied by 36 degrees, which is going to give us 72 degrees. Very simple indeed. Okay, so BOD is 72 degrees. Then BCD. BCD is this angle here. BCD is this angle there, this angle there. That is our BCD. How do we find the angle there? Very simple. So remember that this is a cyclic quadrilateral. Remember from the first lesson. So this point here, okay, 1, 2, 3, 4. All the 4 points touching the circumference. What can we say? Angles in a cyclic quad, okay, the opposite angles of a cyclic quad add up to 180 degrees. So meaning the angle at A and the angle at C, when we add them, they should give us 180 degrees. So meaning, I'll simply say, for me to find C, I'll simply say B, okay, so B, C, D is now going to give me 180 minus 36 degrees, not 360 but 36 degrees, minus 36 degrees. This is now going to give me 144 degrees. 180 less 36, so I'm going to have 144 degrees. That is my angle BCD. Great. So far, so good. If you are liking, you are enjoying this lesson, please give it a thumbs up. Stay with me because very soon we are going to close this lesson. Okay, so now let's look at the last question. The last question is angle CBF. CBF is this angle here, this angle there. That is our CBF. I hope you're able to see it. This angle here, that is our angle CBF. How are we going to find that one? Let's just clear this so that we can work nicely. Okay, let's clear that so that we can just work nicely. Okay, now here we simply say, okay, I know that this is my 72 there. I have 72 here, and I can use the tangent properties. Okay, I can use the tangent properties for me to find what I have been told to find, which is angle CBF. Right, so I'll simply say, okay, this angle here is 1, look at this, this is 144, this angle here is 144, so 144 degrees. The angle here is 72 degrees. Are you able to see that? If that is 144 and that is 170, that is 72 degrees. Now remember, this, when you look at it here, this has got how many sides? 1, 2, 3, 4. Now this is a quadrilateral. Now it's not a cyclic quadrilateral, it's just a four-sided shape, which is called a quadrilateral. Now the sum of angles inside a quadrilateral will give you 360 degrees. So for me, I'll simply say, okay, this one is going to say, okay, let's say angle. This is part C of the equation. So part C of the equation. Now I'll simply say angles inside this cyclic quad will give you the same. Now remember, again, we can also say this here from there, from the center to the circumference there, I have the same distance from the center to the circumference, meaning that these guys are the same. This and this, they are the same. Are you seeing that? These are the same, meaning that, okay, the angle that I'm going to find is going to be like this. I'll simply say, okay, 360 degrees, 360 degrees minus what is there is going to give us 144 plus 72 degrees. Now, because there are two angles there, and you can see from the shape that these angles are going to be equal. You can see from that shape that these angles are going to be equal. What we're trying to find is the angle there. Okay, then use it to find the angle here. So I'll simply say divided by 2. So this is going to give me 360. Okay, so 144 plus 72. I'm going to have 216. So I'm going to have 360 less 216. The result divided by 2. So I'll say divided by 2. So I'll say 360 minus 216. I have 144 divided by, so here I'll say 144 divided by 2. Okay, so what we're going to have is 72 degrees. 72 degrees. So meaning this angle here is 72 degrees. This angle there, this is 72 degrees. That is also 72 degrees. Can you see that? Now, if that is 72 degrees and this is 72 degrees, I know that, okay, from here, I know that the angle here, look at this. I want you to see it nicely. This is a radius. Can you see that? And this is a tangent. That simply means the angle here is going to be 90 degrees. From there to the tangent, I have a 90 degrees there. Can you see that? Now, out of that, I know that there is 72. What is this angle there? So, meaning the remaining angle, this angle here, is going to give me, this angle there is simply going to give me 90. So, angle CBF is simply going to give me 90 degrees minus 72 degrees, which is going to give me 18 degrees. Okay, 18 degrees there. So this is going to give me 18 degrees as my angle CBF there. This is part C of the equation. And I'm done. As simple as that. Really, if this video has added value to your studies, to your revisions, don't hesitate to give it a thumbs up. Please like the video, okay? Share the video to your WhatsApp groups, and let's together revise through as we prepare for our exams. Really, this has been part 2 of second theorem from your friend and teacher Kaunga Samuel. It's goodbye.